A very good afternoon, everyone. I welcome you to Saturday Talk. It is our pleasure to welcome Mr. Chandrashekhar Deshpande, founder of Chandra Systems Pune, an IIT Bombay mechanical engineering graduate. He brings over 45 years of experience in mechatronics, machine tools, design, and manufacturing. He has worked extensively with global industry leaders throughout his career. Today, he will speak upon proactive thinking, a century old technique, exploring how structured planning, specialized knowledge, documentation, and sound decision making can help us anticipate problems and achieve better professional outcomes. Sir, over to you.
Thanks for giving me opportunity to talk and welcome everybody to my presentation. So today's topic actually is a combination of a discussion between Harish sir and myself. Okay, so basically I was initially going to talk on my favorite book, Think and Grow. Okay, but Harish said that let us make it slightly more proactive. So I say, and he gave the title Proactive Thinking, and this is how our presentation has evolved. And he wanted to focus on certain definite outcome. So we'll go to that. Now, this presentation is based on certain things. So let us be knowing what they are. Firstly, it is based on a century old way of working. I would say work philosophy, and that is known as Think and Grow Rich philosophy. Okay. So this is starting point, and this philosophy is an outcome of way of working, philosophies, then techniques, I would say the skills of 100 and plus US businessmen. And to name a few, firstly it is Andrew Carnegie, then Henry Ford and Alexander Bell and Thomas Edison. This is what we see here. And Andrew had told this Napoleon Hill, the wording goes like this. See, there are fixed rules of success in any venture, whether it is business, it is research or whatever it is. And what happens is everybody stumbles upon them, reinvents them and goes ahead. So it is for the mankind that we have to document it. And that is how this documenting of these techniques, or I would say principles, has come up. Okay, so this is a proven methodology which we are going to use for our problem solving activity. So there is starting point. Starting point is we have our certain problems, and then we need a direction, and the direction is given by these techniques. Okay, now and for this illustration I am taking reference of certain cases which I observed in recent week that will come to know. So there are three illustrations. Two of them are basically mechatronics oriented and one is general purpose, very simple cases which will introduce to the way we think in mechatronics also. Very simple. So let us go ahead. So next slide please. So what I'll tell you my brief background. Basically I am from IIT Bombay. My entire career has been mechanical engineering and that too in mechatronics. I was associated with machine tool division of Tata Motors for more than 20 years. Then I started on my own and I shifted to mechatronics, then new product development, etc. Now at present I'm working as Chandra Systems, founder of this small company, and basically are working with global companies. There are certain export order design and manufacturing, and we now aim to partner with global OEM leaders and technology companies in coming future. So basically we have integrated product development solution, right from concept to solutions to CAD models to manufacturing plans, testing plans, and then even assembly plans, and with manufacturing support service. So now the case, we'll study the case a bit in detail, I would say in technical terms as well as common sense terms. On exactly 1 week before, on 5th and 6th July, we had flash flood. I'm staying at Talegaon. We have got two hills adjacent to us, and then because of heavy rain, there was flash flood like situation in our society. The arrow is that basically that is a road, a circular, and on the top's right side there is another premise that is a school, and there was a lot of flood coming from the school area, from other areas. In short, we had a flood in our society and entire road was blocked, and it affected number two things. One is the lift under breakdown, it was not available for 2 days, and then our water supply system, even drinking water supply system, was not working because the underground water tanks, they were flooded with mud water. Okay, so this was the situation. Now, I would say there are three aspects or features of this. One is, was there any prevention possible? Was there any risk mitigation possible? And what was the level of communication? In this case, basically, we need to have, for communication, there has to be a hazard communication system, and for preventive action this should not happen, etc. One is, we have to have an effective drainage system. Then we have to have protective walls, which were missing actually, meaning it had 2 years before it was damaged and it was not repaired at all. And a risk mitigation plan, meaning we have to have a risk mitigation plan in place and in action. That is a document. That is why I say proper documentation, proper system has to be planned, anticipated. And so, but these things were missing. So what happened? There was chaos. There was almost like warlike situation in our society, and everybody was confused. Entire life was upset for 2 days, actually, I would say. Now, what does that think and grow rich philosophy say? These topics will come in subsequent slide. One is specialized knowledge, meaning you have to know how damage will take place, then what is the risk mitigation plan, what are the communications required. Then you have to imagine, you have to visualize what may happen. And then most importantly, you have to have an organized plan. And then somebody has to take the decision. So basically what happened? There was no analysis, there was improper communication, and there was no documentation, there was no planning, because of which this situation came up. Okay, now we'll go into, this was overall simple management situation which we see everywhere, common life situation. Now we'll go bit into mechatronics, that is case number 2, lift breakdown. Here this is a simple manual sketch of I would say simple schematic of a lift system. Okay, what happens, since the lift starts from P1, which was flooded, okay, and it goes up to 12th floor. So as you know, that lift is run by rollers on a certain lift guide. There are 4 or 6 numbers of them. Then each floor has a sensor. In this case, parking 1, that is P1, has sensor LSP1, that limit switch of P1. Okay, P2 has limit switch P2, and the stop spring and the emergency stopper at the bottom. So they are at P1. And you see on the upper side, similar system has to be there. What was the status? The sensor and limit switch LSP1, that is the bottom sensors were damaged. Somebody decided that the lift will travel only to P2, not P1. Okay, that is also, that was sort of information given, message given. And then there was no, I would say, proper communication or control system updation, because of which there was subsequently an accident. That lift traveled on its own to P1 when a power outage took place. Okay. And then controller program was not changed. Communication was not up to mark. There was only simple notice displayed. So basically there was definitely a safety hazard. Here what had happened, because I knew something, I took some action. So on the left side you will see WhatsApp communication. I clearly asked whether lift control program is changed or not. The recipient or somebody who was handling the situation did not understand what it is. He said yes, program is changed. But the program change did not mean that you put a notice, that is, please do not press button on P1. Lift will come from P2. Okay. And what happened? I will tell exact time. At around 8 o'clock, lift, there was a power outage and restart. At that, when the power came, because of power surge, lift automatically went to P1. I see that snap is there. So what happened? Number one, the controller was not changed. The communication was not sent. And most importantly, the entire mechanism and control system was in dangerous situation. It was not supposed to go to P1, but there was no stopper. See, if I want to stop somewhere, there has to be a limit switch and there has to be a mechanical stopper or spring, so that to absorb the energy. But that was at P1. For P2, if you want to stop at P2, you have to have that arrangement over there, which cannot be done. So under any condition, you have to have correct sensor and control setting. So now the problems are sensor and limit switch damaged. Ideal is the switch. Another thing is the switch can be waterproof. For example, You can have proximity switch, which is waterproof switch, instead of a regular limit switch. Then the spares were not planned. So there was delay in lift repair. So what the book says is you have to have completely organized plan and specialized knowledge. You have to know how the circuit works, what are the parts available. Next is there was simple notice and controller program was not changed. So what happened, because of which at voltage spike, the lift went to directly P1 when there was nobody inside the lift. Now there is another safety concern. If somebody was there in the lift and without any notice, without his command, if the lift went to P1, there could have been accident or even an injury to person. Then this point was missed during this all communication. And so what happens is, for controls or in lift sort of thing, where is the mechanism, machine is involved, human life is involved, you have to have complete plan, you have to have correct decision and specialized knowledge. Then I told you about safety protocol which was bypassed. Then you have to have complete organized plan for that. And safety hazard due to accident travel, that was one of the problems. We have to have proper documentation, machine safety documentation. This documentation never existed. So what the book, or I would say the standard practice says is, you have to have specialized knowledge, you have to imagine what will happen, you have to have an organized plan, you have and there were no safety concern and improper communication. Now just think for a while, this is a common mechatronics control system of any mechanism. Just see if you have witnessed this sort of situation elsewhere in your previous life experience or any elsewhere, or you see even at a railway station, do you see situation like that? Because I confirm the observation that with power outage, the lift traveled on its own. See, I would say around 1995, I would say now 30 years before, we were making a CNC machining center. It was a column and there was some tuning going on. It was not complete, and then there was a power outage. Power started again, and then it was May, and there was lightning. There was a voltage spike. Because of that lightning, basically there was an error, and entire column on its own moved against stopper because of certain programming, that is, I would say, referencing or zeroing. That is what is called in control system. So we have to know all these things beforehand and in totality. So we go to next problem, which is very common: water supply failure. See, it is slightly blurred, and because it is slightly complex also, I'll just briefly tell. On left side, you see a pump. Then there is a pressure setting, that is a pressure adjustment valve. Then there is a joint, I would say. And then after that, there are pipelines going. We have got 6 buildings, and ours is last building, that is building A. Okay. Then there are halls that go to each building. And to the our building, there is P1, that is parking 1. P2, parking 2, 12 floors, and then overhead tank. Okay. The water goes via the valve, which is half open, shown right now, and goes to the overhead tank, and then after that it is through another opening, it goes to all flats, and there is in between a valve, pressure reducing valve. Now what was the status? There was complaint that water is inadequate at floor number 12. And in any case, there was water problem, supply problem. So there was possibility of inadequate pressure. At inadequate pressure, there was possibility. I'll tell you why. Then there was improper input valve setting, which is shown here, valve open, and possibility of improper pressure reducing valve, which is shown around 6 and 7 floor. And basically, what happened is then, the 12th floor component, there was no water supply, despite supply being on for longer. And another thing is, pressure setting near pump was reduced without regard or any other issues. Okay, now what happened here? See, the joint which is shown on the left side had failed. There was some leakage, so the joint was replaced. It is simple L joint, and because it is high pressure line, so there was failure. And in order that the joint doesn't rupture again, the pressure setting was changed. And somebody has read the pressure setting around 80 psi. Okay, now if we see the pressure setting that is minimum required based on basic calculations and simple mathematics is 78 psi. With considering the pressure drops or the pressure drop required for good flow, it should be around 100 or 108. So 78 is bottom line. Ideally, it should be around 108, and setting was around 80 or 85, let us say. These are approximate figures, but the phenomenon had occurred, the figures may vary. Okay. Now, what happened is, meaning the pressure was varying, the joint was failed. Because joint failed, the pressure was reduced. And because the pressure was reduced, the water supply was not up to the mark. And again, somebody had played with the valve. It was kept half open, and the pressure reducing valve not functioning. Now, here we see that the problems are inadequate water pressure, improper valve setting, then improper reducing valve setting, and then somebody had fingered with this regular valve that particularly the valve near the pump, any considerations are one. So all these were done in isolation without regard for the systems. That is why we say that system thinking is important. Now, ideally is standard operating procedure and operation manual with every machine or every system. This is a mandatory thing. It was a missing, nobody knew, and rather people were not literate to the figures or the numbers that are required. Now, what the book or the guidelines say is you have to have organized planning. There has to be a correct decision, and you have to have specialized knowledge. Okay. So what we see is there is no documentation, no analysis, and arbitrary decisions. And again, in short, we are telling is that ideal pressure should have been above 100 for proper water supply because of basic hydraulics principles. Now we have seen basically simple cases that occur around us. I took very simple and day-to-day life examples so that I can communicate properly the need for a correct system. See, what happens is, we have a set of proven principles, as Andrew told that we have the knowledge, but it is not passed on. And so now coming in today's time, we know that they are documented. Luckily, they are available with proper updates also. Now, it is our responsibility that we understand those techniques and start applying. Why? Because it is like a vector. The starting point is where we stand today. Our aim is we have to have good success and appropriate performance at professional life, and we need to direction. The beauty is the direction is already given. It is only that implementation is required. That is why I am highlighting the basically the listing the techniques that we can take us. Okay, now we talk of think and grow rich, which is, I would say, now in the book says 13 main principles, but in order that we stick to our objective, I am picking only few of the principles. Okay, on the left side, we have got the name of the principle as per book. Then what can be the application of principle, and to the side, I would say at work or at field, what will happen. Please desire. We must have a desire that will get our target and our objective and will succeed in our venture. So for that, what is necessary is firstly we have to have well-defined objectives and goals, and we have to have motivation to go towards it. Then for that, we need to have faith, auto-suggestion. That is, in short, we have to have the confidence that we'll go to it. That is, we have to have a positive mental attitude. Next principle which is applicable is specialized knowledge. This is all expertise, technology, the special techniques, all sciences, theories. Now we say that even AI and all the state-of-art technology that is coming for drives, sensors, mechatronics, robotics, etc. This is specialized knowledge. This is absolutely essential for our success. So for that, what we need at work, we need technical database and all the records. We have to have a record of observations. And secondly, we have to observe neatly what is happening around. We have to analyze the problem. We have to do analysis that is required for the work. Then there has to be a database that is generated during the work. Then there has to be innovation, and there has to be teamwork. Because since there are multiple experts, there has to be proper teamwork. Otherwise, specialized knowledge cannot be put to use. Next point is planning. Whatever we want to do, there has to be a pre-thought plan, put it in work, and then implement. So, there is one way working I would say working process: plan, do, check, act. So basically, planning is the first place of any action. So we have to have clear and structured approach to solutions and details. So what is important is, please note, documentation is absolutely necessary. In operational calculations, critical path analysis, there are various techniques, and most importantly, inter-team cooperation. No planning can work if there is no inter-team cooperation. Then another thing is, there is technique called mastermind. Basically, mastermind is basically multidisciplinary teams or multiple experts, and then it is associated with intelligent decisions and experience, meaning there is versatile experience, past data, and multidisciplinary teams. So all come together and assist our specialized knowledge and guide us to our goal. Another thing is imagination. That is, we have to be innovative, new ideas. We have to have new ideas. Then there has to be structured brainstorming. Then there is one thing called synthesized imagination. That is how to generate ideas, something like brainstorming. That there is a process for that. That is illustrated in the book. And its practical implication is, that is, there are breakthrough ideas and solutions. We have to come to that. And then creative imagination is what is important. Another, lastly, topic here is persistent, meaning we have to persistent effort, sustained effort, hard work, and channelized effort. So with all these our modified attitude approach. Now, these are some other principles that are not covered in the Think and Grow Rich methodology. Rather, this particular law of success was written earlier. Now, was again the same way. The principle is a definite chief aspiration and passion at work. We have to be passionate towards our work, our objective, and our way of working. So, because then only we can have proactive sort of working. So what they talk is doing more than paid for. That is, in today's work, service orientation. So give something extra, run extra mile at your work. 1 minute. Specialized knowledge. Okay. So accurate thinking is associated with specialized knowledge. Okay. And what is then it is cooperation. There has to be harmony. There has to be teamwork. And teamwork, cooperation, or accurate thinking, everything can come when you have properly planned, you are documented. So we see that as it is in formal corporate world, because there are certain formal steps and there are teams, so communication is important. Documentation is part of communication. Also, analysis, and then the record of it. Here we have seen that what are basically various steps as per the book. Now we started with our problem statement and then studied these principles, which are, I would say, age proven, and then we're talking about being proactive. I'll take more time on what makes us proactive. So then you have to have evaluation. Then there is a proposal. After that, design, initial, I would say, concept. Then there is solid modeling. Solid modeling, basically, unless and until you put it properly, that itself is documentation, no? The storage in archives and all that, storing of latest model and communicating to everybody at the correct stage, then manufacturing drawing, that itself is been documented. Then there has to be manufacturing plan, then there has to be inspection plan, there has to be test plan. So all these plans are actually is basically planning and documentation goes together hand in hand. And this is very vital. Then comes calculations, analysis, and stage reports. See, we have to have stage reviews or periodical reviews, and then all analysis has to be done at the right time only. Because if a part is going to fail, we have to know it before it is finally designed. Or if a mechanism is not adequate, we have to know beforehand. Then as we go ahead during the projects, there are discussions. What happens many times, there are no file notes of discussions or there are no minutes of meeting. Or even if a decision is taken by somebody, then he has to have a file note of it if there is no meeting. So that is again record keeping and documentation. Record keeping is basically putting up everything with proper folder structure. In old time, it has to be project files. The next point comes is accuracy and exactness of reporting. In my case, in case of the lift, when I asked of courtesy, whether the controller is modified or not. The report I got is, yes, it is modified. That person took controller or control as a notice. Notice is not control. It is just one message which can be turned off. It was actually turned off. I was thinking in terms of the electronic control. So reporting or communication was not accurate. It was not exact. And then multi-team interaction. There are in your projects there will be hydraulics team, then there will be assembly team, then there will be controls team, then manufacturing team, designer, vendors. So there has to be proper interaction and communication for number one, timely completion and more and safe completion of the project. Safe and excellent completion of the project. Now point comes there is specialized knowledge. Specialized knowledge is something this is very much important. This is being proactive. If you are proactive, you will on your own go and learn about various techniques, various methods. What is the state of our technology? What is the way in which I can improve my work? How I can improve my design? Then what are my competitors doing? So all the specialized knowledge, I would say, in today's era of improving technology and AI, this is what is important. The person who has latest knowledge has better chance of survival, but at the same time, he can survive in a better way if he has proper documentation, proper analysis and teamwork. Because if specialized knowledge is not associated with proper documentation or proper analysis, it is not going to succeed. And then over and above that, service orientation, you have to be customer centric. So all the departments, right from proposal, say, I would say initial concept, modeling, manufacturing, everywhere we have to have service orientation. Service orientation meaning, are we anticipating our customers working? For example, I may have manufacturer or the owner of the company as one of the customers. Also, I have the machine operator or mechatronics equipment user as another customer. So, am I giving proper service? Am I oriented to service to my all of customers? Now, there can be internal customers also. Designer has machine assembler as one customer. So meaning all these aspects, we have to think proactively. That is why it is called as proactive method. So this all is likely to make us more proactive. This change in attitude or approach, I would say, will get us to our target from where we stand. Okay. Thanks. This is what I have.
I think from the perspective of an engineering company, especially since a lot of the work happens to be so dynamic and challenges, especially on site, can become really dynamic. I wanted to ask a question about translating the learnings that we are developing inside a system into actual execution. So, how does one determine that there is sufficient analysis and now it's time to act?
Okay, so here, this sort of thing, when it happens, it can be easily solved. Number one, firstly, you have to have proper plan. Number one, the designer or the whosoever the stakeholder is, there has to be manufacturing plan, meaning right from how you convert your solid models into manufacturing design into, I would say, manufacturing that part, meaning what are the tools required, what is the fixture required, what is the machine required. Up to that, we have to go and anticipate. We may not work on it on our own, but we have to anticipate. This is where typically the problem comes. So that is, we just trust something the user doesn't understand. There is lack of communication. And basically part is not manufactured correctly. Now you are talking of end customer. So let us say we are talking of somebody who is assembling our unit at site. So there has to be assembly manual, then there has to be assembly plan, test plan. If there is test plan, how a designer expects the machine to be tested, and all these have to be discussed beforehand. I'll give you one case. I was in Tata Motors machine tool division. I'm talking of around 1995 or so. At that time, there used to be release meetings. So machine release meeting, for that representative from every department would come. There were representatives for manufacturing, that is machine planning. Then there were representatives from assembly planning. There were representatives from machine shop, even end users. So all used to discuss how we are going to execute the design to the end. So everybody used to look at from one angle. And once the meeting was successful, then the end person, let us say in your case, the assembler would beforehand, what is the surprise in it? Actually, in that case, there will not be any surprise. The problem comes if there is poor communication or improper communication. If there is no document, the assembler will not know how to assemble. So he will use something which is not anticipated. and the end user will not know. In some complex cases, the designer has to start anticipating the assembly and manufacturing. There has to be design for manufacturing and design for assembly. If design for manufacturing and design for assembly is implemented properly, most of the problems are solved. Then there has to be a test plan. And as I discussed earlier in my second case, there has to be a risk mitigation plan. We have to first identify what are the risks in execution, that is, risk during assembly, risk during testing, and risk during transportation also of a product, risk during end use. So all these have to be understood, listed before that, and mitigated at design stage or at appropriate stage if required. I think this will solve the problem, in my opinion.
Absolutely, sir. And I think in addition to what you're saying, I would just like to add a point that even communication becomes very easy when we have a proper plan. Because let's say such as your someone of your stature who has worked across different fields in engineering such as mechatronics, machine tools, design and manufacturing. Someone like you and your experience will have the ability to understand different problems. But a lot of the engineers, when they're starting their careers, they have good specialized information about one domain, but that might not necessarily translate into a complementary domain. So good planning can also largely aid in the process of effective communication.
There are two things. One is the planning has to be there, and there has to be record. For example, when a designer is working, does a designer a rough book or a ledger with him, or a book, I would say. Because I have formed the habit that I have for every project one notebook, and as we progress during the project, I just go on noting what are the decision taken, what is the calculation of it, why it is coming up. So I have a rough database with me. I convert that into a required document as and when it comes. So there has to be minutes for meeting, there has a project notes, file notes, calculation, stage report, and if there is a change, automatically there will be a note of accordingly. And now, because of now, we have so many facilities, word is available, and camera, mobile, and all that. Earlier, we used to make these reports only by manual writing or computer typing. Now we can make with use of photos also or images, sketches. We can simply sketch something, take a snap of it and put it in the file and keep it stored in the computer also. So that is also possible. So the documentation has to be perfect.
I have one question, Chandra.
Yeah.
The question is this: that how do we know that we do not have the specialized? They start designing something, or they start making something, or even in service, and they think that they know, they have experience, and that experience may not be sufficient. That experience may not be, complete. How do you know that what do you call, the knowledge is not a specialized knowledge, or there is something lacking in it until there is a serious problem which is.
I think you use correct word. You said they think that they know, or I think that I know. Okay, so there has to be a periodic check in literature. In old time, I used to go to libraries and search for publications, magazines, catalogs. I'll tell one classic case what happened when I was actually a trainee. There was something new input. It has to be communicated. So I communicate what I learn. I communicate my learning to others. So if all others communicate that to me, also in my field, I have to go on knowing what is new. I'll tell you one classic case. I was designing slides. But precise slide. Initially, there were rectangular guideways, that is iron door contacts. Then came basically polymer, that is tenside sort of thing, which were stuck, and polymer metal guide with reduced friction. That was next. That is sliding, but using polymers. Okay, there was some pilot possible. Then came linear guideways with ball bearings. So basically THK, Subaki or star type guideways. So we started using. Okay, so this was on guideway front. Then on ball screw side, initially we were using lead screw, then came ball screw, then there was couplings and all that. So around 95, I was developing complete slide using this. That is, there is some a guideway there. There is a rotary motion to linear motion transmission. But now there are certain German elements available in which there is a precision ball screw and guideway both in most compact fashion. I was really stunned to see that feature in 2021 because I was dreaming of a compact slide unit which was not possible at that time. So this is because of availability of certain element in the same field. This is evolution or progress or development. So I have to know what is happening in my field. This is state of art technology in my field. Same thing happens with controllers. Same thing happens with polymers, rubbers, sealing. I'll tell you one classic case. In old time, we were putting oil seals and oil seal was rubbing on directly ground shaft. Okay. So rubber handspring, the pressure would cut a groove on harder shaft. Okay. Later on came introduction of a ceramic coating at the contact, and ceramic coating did not wear. So this is improvement. So for that, the person has to be in touch with what are the developments and progresses in that field. So for that, there has to be a study or research and development in that. So openness to new news, new developments is absolutely necessary. This is why we can have specialized knowledge. It has to be there. And another thing is this activity has to be planned properly.